All right. I can't tell if it's recording or not. I guess it is. Um, so we'll just go with that. Hopefully, I won't have to redo it later. All right. The purpose of this is just to give you a basic idea of hurricanes. So the idea is, you hear about hurricanes all the time in the media, and you probably know something about it. So I'm not going to do all the basics, but I'm going to just kind of wade lightly through all the hurricane science to just get you up to speed on what hurricanes are, how they're forecast, what ingredients we look for. And then at the end, I'll talk more about impacts and I'll talk more about hurricane insurance, just because in the last year I've gotten a lot of questions about that. And I think some people are interested in that. If you have a question about one of my slides, you are welcome to unmute and ask it right away. I don't require you to wait until the end if there's something to clarify. If you have a more broad scale question, I think you can probably wait till the end to ask that. And so let's go ahead and get started. We'll see how fast the computer is today. There we go. So this is basically the outline of what I want to talk about in this class. First, I'm going to talk about what is a tropical cyclone, how does it form, where do they form, and then some impacts, some forecasting, a little bit about preparation for hurricanes and tropical storms. And I am not going to go into depth on this because it really depends on where you are. I've put other things in email before, and there's certainly a lot of resources online. And then at the end, I'll also talk a bit about hurricane insurance because that has come up. So when we talk about a tropical cyclone, cyclone is just a general term in the northern hemisphere for low pressure. And cyclones generally in the northern hemisphere rotate counterclockwise. I know a lot of you probably have digital watches like I do, so you don't really think of clocks as going clockwise or counterclockwise, but it means if you're at 12, you're going to the left. So you're turning counterclockwise. Um, and that's basically the circulation that's driven by the pressure gradient of the atmosphere plus the rotation of the Earth, which gives rise to something called the Coriolis force. Um, and friction helps to pull the air into the middle. So on the left-hand side, you kind of see a diagram that shows wind going into the tornado, or in this case, into a tropical storm or hurricane at the bottom, and then it kind of spirals up through the eye wall and then goes out. And usually at the top of a hurricane is high pressure, so it's going out clockwise instead of counterclockwise. You can see that a little bit more in the right diagram where you can see the low at the surface and the high above the surface. And in that area of clear air that forms in a hurricane, you get something called the eye of the storm. You usually can only see it if it's a hurricane. Usually tropical storms do not have eyes because they're not strong enough. The winds aren't strong enough to clear out the middle of that storm. So you've got the eye walls, you've got the eye, high pressure aloft, um, and then you get these rain bands. It's not continuous rain around most hurricanes and tropical storms, but it comes in bands. So you get these, really heavy rain, and then it will let up for a while, and then you'll get another band that comes in. So the tropical cyclones are almost over the world, and we'll talk about this a little bit more when we talk about the climatology of tropical cyclones. But they do vary in speed, size, and intensity. Um, and so they have some other names in other parts of the world. They can be called typhoons if they're in the Western Pacific. They can be called cyclones if they're near India. So if they're in the Indian Ocean there. But in the area that's around the northern hemisphere, we usually call them tropical storms and hurricanes. If we look at how they kind of develop over time, we'll talk a little bit more about this in just a minute as well. Usually they start out as kind of this amorphous blob of thunderstorms. If you look on the left diagram there, stage one, you might think there's a little bit of organization there, and you have to look at the surface winds to really tell if there was a spitting kind of motion. Eventually, you usually get spitting motion because of interactions between storms and so on. Once you get a spitting motion, the center of the storm tends to drop pressure. The pressure gets lower and lower, which means basically a lot of atmosphere is just leaving. A lot of the air is just leaving that part of the atmosphere and is being pushed out, especially at high levels. Um, So, it usually starts off as this blob, and if you look at a satellite picture, you're going to often see these during tropical storm season. Um, and so at stage two, it's starting to get a little bit more organized. You can start to see some of that curvature, that circular motion. And then by the time you get to stage, and that's usually like a tropical storm, stage three is when it's highly organized. You have really almost a uniform cloud cover over the whole storm. We call that the central dense overcast. And there's often an eye in it. Um, and that eye is where the lowest pressure is. And the strongest winds are usually right around the eye. Although, if you've ever been in an eye, the eye itself is actually quite calm because the wind is whipping around in one eye wall. And so, if you get into the eye, the winds will calm down, and then you're going to get into the other eye wall as that eye passes over you. So, you get really strong winds then from the other direction. Um, so it could be kind of cool. I've never actually been in an eye, but I've seen plenty of videos to be in the eye and be able to look up and see sometimes clear sky up there. But then that's a very short time period, depending on the size of the eye. The eyes can range from less than a 10-mile diameter to sometimes 40 or 50 miles an hour. It just depends on, or 40 or 50 miles across. Just really depends on the strength of the storm and how it developed. It also can change over time in the lifetime of a storm. And so eyes sometimes will pulsate a little bit. They'll get a little bigger, they'll get a little smaller, and they can also go through something called an eye wall replacement cycle, which I'll talk about a little bit later. So usually if there's a center of closed low, if we know there's a center low pressure there somewhere, we call it a tropical depression. But the winds are usually below 40 miles an hour, and it's very disorganized. Once that low pressure gets lower and the winds get stronger, so if they're between 40 and 74 miles an hour, 75 miles an hour, then it's classified as a tropical storm. And then if it gets to the point where the winds are over 75 miles an hour, it's classified as a hurricane. And then, as you know, hurricanes have different classifications as well based on the Saffir-Simpson scale, based on just their wind speed. It's important to note that you don't entirely get the worst impacts necessarily with the highest wind speed. You certainly get a lot of impacts, but you can have really bad impacts even with a tropical storm or a Category 1 hurricane. It just depends what kind of impacts and where you are. They're only classified by wind. They're not classified by storm surge. They're not classified by rainfall or anything like that. So a weak hurricane can cause big impacts. And you'll see that when we talk about Tropical Storm Alberto shortly. So generally, the way that a tropical system will form is you'll get an area of low pressure. This is happening all over the atmosphere over time. That air is constantly trying to balance out the mass of particles over the surface of the Earth, and so some areas will just get warmer, and often if they're warmer, you have rising air, so the pressure goes down. In other areas, there'll be a little bit more air, so the pressure will be higher. Pressure is just a measure of how much air there is above you. So you start off, usually warm water is needed. You have to have ocean water over 80 degrees Fahrenheit for there to be enough energy from that water to really cause that rising motion that really generates the start of the storm circulation. And that's why this time of year, we don't see a lot of hurricanes developing in the eastern Atlantic Ocean because the water's not warm enough yet. Last year it was really warm, and so the season started a little bit earlier. This year it's still warmer than average, but it's not quite as warm as it was last year, and that's going to affect the number of hurricanes we think we'll see. So you get this wind coming together. The winds can't go down because the water's there, but they could go up, and so the winds go up, and as that moist air rises, the water vapor condenses and forms clouds. That provides more heat. And so you start to develop the circulation. When it gets up to the top of what we call the troposphere, which is occurs right about the level that cross-country jets fly at. So it gets to that, and it's really not possible to go up because the atmosphere gets warmer as you go up after that because of ozone. And so the air spreads out at that point, and it's got to come down somewhere. So you get the circulation where you've got air rising in the center of the storm, spreading out across the top of the atmosphere and then sinking down away for it. The sinking motion around the outside of the hurricane can lead to very dry conditions if you're far enough away from the center of that storm. So we have had many storms that have actually made our droughts worse because they went so far away from us that we were under that sinking motion. We didn't get any rain at all. So that is something we watch. One of the storms that really comes to mind for that is Hurricane Matthew, which hit the East Coast and caused a lot of rain on even the east coast of Georgia, but most of Georgia was in that sinking air, and it got very dry. The drought got worse. So that is something to keep in mind, that tropical storms are an important source of rainfall for us in the summer. Maybe 30 to 40% of all the rainfall in Georgia in the summer comes from some kind of tropical system. It doesn't have to be an organized storm, but some kind of tropical system. And if we don't get those, then we're going to more likely go into a drought. So we got this air coming in from over the warm water. It's going up. Wind is blowing out, and you start to get that circulation. You will note it's got to be at least 5 degrees latitude away from the equator, because that latitude affects the ability of the air to curve around. So in order to get the circulation, you have to have the air reacting with the rotation of the Earth. If you don't have rotation on the Earth, you're not going to get hurricanes, which is really interesting thought, kind of an interesting thought process that you might go through if you wanted to think about that sometime. And they do that sometimes in meteorology classes when they're trying to see how well you can reason. They'll ask, what would happen on a planet if you didn't have a rotating planet? Well, there's a lot of different things that would affect things. And hurricane development is certainly one of those. When we think of the traditional kind of hurricane, tropical storm that we get, we think the ones that form in the eastern Atlantic Ocean. Basically, a wave of low pressure comes off of Africa, coming from east towards the west, as it does in the tropical region. So you start to get this amorphous blob. Sometimes you can see those well onshore on satellite maps. And then as it moves to the west, it starts to get some organization. So it might be a disturbance and then a depression when it gets a close low, and then move on to a tropical storm and often a hurricane. That storm is being pushed around by winds about halfway up in the atmosphere. And they're going around this area of high pressure that's called the subtropical ridge, which forms over the ocean every year. It's the strongest in the summer. So that is really what's pushing. Sometimes a ridge is a little bit farther to the west, and that's more likely to push the hurricane into the Gulf. Sometimes it is smaller and it's more to the east. In that case, you're more likely to get a storm that's just going to go up through the central part of the Atlantic. And we're not going to really see any impacts from something like that. We call those fish storms, because the fish are really the only ones that are affected by that and commercial sailing as well. So that's very typical, but you'll see that not all storms form that way. Structure of a hurricane, like I said, you have this eye in the center and the eye wall around it where the strongest winds are. The eye wall doesn't have to be closed. Sometimes if you've got really dry air that's coming in from the west, you remember it's going around counterclockwise, so you're pulling air off the land when it gets close to land, and it's often quite dry. That can erode the eye wall sometimes, especially as the storm is starting to come on shore, or if you're close to a continental area. You see on the satellite picture here, there's spiral bands where the heaviest rain is occurring with lighter rain in between. On satellites, they show up as tall clouds because thunderstorms are tall clouds. And so you can see that this is a visible satellite picture. If you look at it on an infrared picture overnight, then you're likely to see that those are really the coldest clouds, because it's the coldest high up in the atmosphere. So if you get tornadoes in hurricanes, which is not that unlikely, they're more likely to form in the spiral bands because you already have that extra energy there from the thunderstorms. A lot of those don't have a lot of lightning, but there is definitely some lightning. I've heard some interesting stories about lightning in tropical storms. And then wanted to mention that storms go through eye wall replacement cycles. There's a little picture of that on the bottom left-hand side, where you can actually see there's 2 concentric eye walls. So you got this really small one in the middle, and another one starts to form on the outside of that, and eventually it kind of cuts off the circulation to the middle of the storm, and that new eye wall is larger than the old one. And sometimes it's not quite as strong, so the storm will get temporarily weaker when we go through an eye wall replacement like that. If it happens close to land, then the storm gets weaker really quickly, and sometimes the forecasts don't catch that. It's very hard to forecast when these eye wall replacement cycles are going to happen, but they do occur, and when they do, it changes the size of the eye. When the eye gets bigger, then of course the area of impacts is also going to get bigger because everybody's going to be affected by those winds, and as well as where the rain is. The picture on the bottom sort of middle is a radar picture of, let's see, I think that one is Ivan, but I could be wrong. It might be Michael. Let's see. 2004, it's Ivan. Um, and that one will show you how grainy, I mean, it's not continuous rain. As you get closer to the center of the eye, it becomes more continuous. But if you're farther out, you have these bands that come through. The bands can be like a state away. They don't have to be close to the center of the eye itself. They can stretch a long ways away. So let's talk a little bit about where hurricanes form. And on the left-hand side here is a map that shows all the hurricane tracks across the world. Have used this before on a test to say why are hurricanes where they are and why are they not in some places. You can see there's nothing that occurs right on the equator, and that's because there's no Coriolis force there, so there's no spin. And if you don't get a spin, you're not going to get a tropical storm or a hurricane. Um, these are all year. The cyclones in the southern hemisphere form in their summer, which is our winter. But you can see by far the majority of all the tropical storms occur in the northern hemisphere. You might wonder what's going on in the South Atlantic, where there've only ever been a couple of them. It doesn't take long if you look at temperature of the ocean patterns to realize it's just too cold. It almost never gets to 80 degrees Fahrenheit down in the South Atlantic. And so it's very difficult to get a hurricane that forms. So the same thing is true off the west coast of South America, because the water, the currents that are there are coming up from Antarctica. So it's just too cold. And so that is a place where you would not expect to see a hurricane. They got plenty of other problems and other kinds of storms, but they do not have tropical storms because it's just not warm enough. You can see there's also a seasonal cycle and when the tropical storms and hurricanes occur. This map on the or this graph on the right here is for the Atlantic. You have a sort of a different one for other areas of the world. We can get tropical storms almost any season or almost any month of the year. I've seen them before in the Atlantic in January. It's very rare, but it does happen. But usually, I mean, sometimes we get them in May. I don't think we're going to get one this year because it's just not looking like there's any waves out there to really cause something to pop up. But some year we do get them in May, and they have talked with the National Hurricane Center about maybe expanding the official season from June 1st, which is when we say it starts now, to maybe May 15 instead. And they're starting to issue forecasts starting for May 15 now instead of June 1st because of the possibility you could have a tropical storm during that time. There's always a possibility early in the year. It grows dramatically when you get to about mid-August, and you can see the number of tropical storms and hurricanes both rises quite a bit by the time you get to mid-August. That's when you're really in the peak of the warm season. The waves are coming off of Africa like clockwork. And so you can get a lot of hurricanes during that time. The peak is right around September 10. So that's the peak of the hurricane season in the Atlantic. It's very interesting because in 2024, we had hurricanes early and we had hurricanes late, but we really didn't have anything right at the peak. So it was kind of a bimodal distribution last year. We had hurricane or tropical storm Debbie the first week of August when there's really not that much expectation of having one yet, although certainly the odds have gone up. And then Helene was right at the end of September. And so that was already past the peak of when we expect storms to occur. There really was not much of anything going on. In fact, it was kind of dry. The drought was forming during that time because we didn't get any rainfall from tropical systems. And so, but the storm season can last, officially ends November 30, but it can last as long as into December occasionally. And so some of the more active seasons have had storms in December as well. If you wonder where and when they form, here's a map that shows formation areas by the month. June is at the top left there, and then July to the top right, and so on. And you can see that early in the season and late in the season, they're mostly forming in the Gulf of Mexico or along the East Coast where the Gulf Stream is. Remember, the Gulf Stream is really warm, and so that can serve as a source of energy for them. And so as we get into the heart of the season, going into August, and then of course September with the peak, a lot more of the storms are coming off of Africa. And so you can see they follow that typical curve pattern. Everyone is different. Sometimes they do weird things like loops. Sometimes they go in one direction and then they change direction and go in a different direction, which happened with Hurricane Andrew in 1992, which was going up to the north, and all of a sudden it took a 90-degree turn to the left and hit Miami. And that's because of the steering currents that were occurring in other parts of the globe that pushed that storm and allowed it to change the direction. But it makes it more frustrating for forecasters because they're not all the same. They're following what's going on in the larger atmosphere. And you can see as we go into later in the season, October still has a little bit in the Eastern Atlantic, but most of it is focused on the Western Atlantic and the Gulf of Mexico and the East Coast, off the East Coast there where the Gulf Stream is really quite warm. By November, there's not a lot that's forming, and most is forming pretty close to North America. And so the early season stuff also is hurt somewhat by having dust coming off of Sahara. So in the early part of the season, it's very typical that we get a bunch of dust that blows off of Africa and the Sahara towards the west. Sometimes it gets all the way here to Georgia. Occasionally we'll find something, Saharan dust in rain gauges. And certainly can contribute to air quality issues in Atlanta and places like that. That does tend to suppress the development of storms early in the season as well, because that makes the dust keeps the sun from hitting the surface, so the surface water doesn't get quite as warm, but it also keeps the air above the surface warmer because the sun is hitting that instead and warming up the dust layer. And that makes it very hard for that vertical development to occur. So if we look at where hurricanes and tropical storms have hit along the east coast of the United States, this kind of shows the color, shows how often storms have hit from 1900 to 2010. And you can see the place that's most likely to get hit is southern Florida, which is not surprising because it kind of sticks out there into the middle of where the warm water is. Georgia doesn't really have very many storms, but you have to keep in mind there haven't been a lot of tropical storms and hurricanes in Georgia since 1900, but the 1800s had quite a few. In fact, the 1890s had 2 or 3 storms that came in from the Atlantic instead of from the Gulf of Mexico. So that was a much more active period. And I'll talk about the one of those in a couple minutes. But you can see we don't really expect a lot of hurricanes coming in from the Atlantic. And part of it has to do with the geography, the curve of the continent there. It tends to move things off. There used to be, it's often an area where the hurricanes are moving around that subtropical low or subtropical high. And so as it goes around the subtropical high, it is more likely to hit South Carolina or North Carolina, the Outer Banks or something like that. You can see occasionally it will also hit New England, but it doesn't always happen. And then there's the storms that move into the Gulf and keep going west. And you can see there's kind of a little bit of a bullseye there near Houston and Galveston, where they had a tremendous storm in 1900 that caused a huge number of deaths. from the storm surge mostly. And so we didn't really have a whole lot. I mean, last year there was only one storm that hit Texas. That was Beryl. It was a bad storm, but usually, I mean, some years they get a lot more than that. Of course, Louisiana always seems to be getting them, and the northern Gulf Coast as well. If they hit the panhandle of Florida and they're recurving, as they often do, then Georgia can get hurricane winds from that. Although not all storms are still hurricanes when they come into Georgia. That becomes important for hurricane insurance. Um, so that can be something that we have to watch for. If you ever get a question about what storms have come close to us in the past, this is a really good place to go, coast.noaa.gov/hurricanes. You can go in and you can, say how many storms occurred within 100 miles of this location. This one happens to be, I pulled it for Darien, and I used 100 nautical miles so I'd capture the whole Georgia coast and then some. It will show the track of every path. You can hover over each of those paths and it will tell you which storm it is. And you can separate it out if you don't want to look at everything that was just a tropical storm. And you can look at lowest pressure. You can look at just a few years if you want. So that's a nice little thing. And I will have that website again on the last page, which is a list of some websites that are resources. But I get that question every once in a while. How many hurricanes have we had at this location? And this is really a good site for being able to do that. And you can do that for anywhere in Georgia or, well, anywhere in the US, although obviously if you're away from the coast, you're not going to get too many. So let's jump into hurricane impacts. And you can see that I've got them listed really at 4 different types: high winds, storm surge, heavy rain and flooding, and then tornadoes. And we're going to look a little bit at those. I'm not going to talk too much about wind. I think wind seems like it's kind of the most obvious because the damage from winds increases as the square of the wind speed. So if you got a wind speed that's twice as strong, the damage is 4 times as much. So that's why it's important even to know things like what the Saffir-Simpson scale is for the hurricanes, because if you have a weak hurricane, it's not going to do anywhere near as much damage as one that's stronger. Storm surge is, when the water comes on shore, it's obviously not going to cause a problem if you're well inland, unless you happen to be right next to a river that's close enough to feel some of that water coming on shore. Heavy rainfall is probably the biggest killer of people from hurricanes and tropical storms if you are not on the coast. And then tornadoes can occur mostly to the right of the storm's movement. And I've got a map to show you what that looks like. So let's talk about storm surge. First of all, when you have that low pressure in the middle of or over the ocean, the water tends to rise up because the pressure is lower. So you get this bubble of water that rises up that comes along with the hurricane circulation. And as the hurricane moves toward shore, that water is getting pushed on shore. It's usually the strongest to the right of the storm motion. And that's because you got the winds that are also pushing on that water. So it's causing, the winds to pile up water. And then you got waves on top of that too. So you're having the storm surge, that bubble of water. You're having wind that's windborne water that's also being pushed on shore, and you're having waves on top of it. And so all of those things can cause damage. It's usually the combination that involves that. I've been involved in some court cases where they were trying to prove that the house along the shore was destroyed by wind before a storm surge got to it and wiped away the house. It doesn't work very well because often you can get a picture of houses that are nearby that were not hit by the storm surge. You can show that they didn't have very much damage from the winds, but then the water kind of wiped away any evidence of whether or not there could have been damage from the wind. And so that's something that comes up from time to time. On the right-hand side here, there's a picture of the storm inundation map for Chatham County. You can see a lot of the county is going to be hit by even a tropical storm. And there are many areas that will feel water from that. And that is something to keep in mind. All the counties along Georgia's coast will have similar kinds of things like that. Emergency management people should be able to provide them to you if needed. There's also, I think, somewhere on the web that will provide you with a way to go in and put in what level of sea level rise you're going to look at and what that will do, and how much land that will cover over time. It's important to know if you have to worry about evacuations, if you have to get people out, because some roads will close before a lot of the other parts of the county do. And so you need to be able to know when that's going to occur. And you need to know which places are not really safe to live in. Keep in mind that, the sea level is rising. And so that means, in a while, these maps are going to be outdated. They have to be redone every so often. It's not rising real fast, but it's rising. And so if you're in an area that's subject to storm surge, then that's something you're going to have to keep in mind. It may also affect house prices in the future. So here's an example of one storm that caused in Georgia that caused a lot of problems from storm surge. This is the Sea Island hurricane of 1893. It formed, you can see it's a very typical late August kind of storm. It formed off the coast of Africa, moved all the way across the ocean, came close, just skirted the edge of the Florida Peninsula, came on shore right near Savannah, and then moved on off to the northeast, following that very typical curve that we get when it's going around the subtropical high. It made landfall around August 27. The max winds that were sustained was about 120 miles an hour, which makes it a Category 3 or major storm. Storm surge was measured at 16 feet or more in some places, not so much in Savannah, because Savannah was just a little bit to the left of where the center was. So there's a lot more storm surge up in South Carolina, because that was where all the winds were pushing the water on shore. So in Georgia, it was probably more like 7 feet in a lot of places. A difference of 50 miles in the track of that storm would have brought a lot more storm surge to Savannah. And sooner or later, it's going to happen. We just don't know when. So storm surge was high. There were a few places that estimate there were probably some areas where there was water that was funneling into a small area where the storm surge could have gotten up to 50 feet in some places. So the wind damage was reported as far as Augusta and Waycross and Midville. It was a pretty large storm, had a lot of wind damage. The official number of deaths was 1,000 to 2,000. Almost everybody believes that was an undercount. I've heard numbers that are more like 300, 3,000, because a lot of the folks that were in low-lying areas, they're indigenous people, the Gullah Geechee people, or slaves that, previous enslaved people that had lived there, weren't always caught, weren't always counted in that death. And almost all of those come from storm surge. You can go in and look at some of the newspapers of the time and just read just really tragic stories. That was what was going on. The damage at the time was $1 million in 1893 dollars. That probably works out to about 50 million now. Of course, that was at a time when there was a lot less development along the coast. And so now if a similar storm hit, you'd expect to see that damage just be enormous. There's one little picture here on the lower left that shows some of the inundation in Savannah. And you might, I think that steeple there might still be of a building that's there, but caused a lot of issues. There were like two other really big hurricanes in the 1890s, and this was just one of them. Hurricane impacts from flooding are really important if you're inland, because the flooding can occur a long time ahead. Hurricane Agnes, which was I think 1972, caused a lot more deaths from flooding in Pennsylvania than it did from anything that happened as it made landfall. And that's partly because as the hurricane went up over the mountains, as the air rose, more of the water vapor condensed and formed rain. And so that's something we really watch for in northeastern Georgia, because there we do have that extra elevation. In Hurricane Helene, there was something called a PRE, or predecessor rain event. A term that's relatively new in meteorology, but it certainly has been observed a lot. You can see sort of a schematic diagram of that on the left-hand side, where you had the hurricane still offshore and bringing in all this moisture. Of course, here in Georgia, we get moisture both from the Gulf and from the Atlantic, so we get kind of a double dose of that. Forming this area of really, really heavy rain that was even before the main hurricane rain rain occurred, you can see on the radar picture on the right-hand side there was kind of a break between where the outer spiral bands of the hurricane were and where this predecessor rain event was occurring. That's part of the reason they had so much trouble in Asheville, because they had already saturated soil before the hurricane rain ever even hit. And so they were really got kind of a double whammy of moisture from that. So these don't always happen. You have to have interactions, usually with some kind of front, to concentrate the development of one of this predecessor rain events in one place. You can get a lot of flooding just from the rain that occurs right around the hurricane. You can see that there's a lot of stuff showing on the radar there. And so that is something we look at. Some of the other flooding events that we've had in Georgia or near Georgia include our record setter for the state, which was Tropical Storm Alberto in 1994. Sort of hit, you can see there in the Flint River Valley. The maximum amount of rainfall from that was 27.85 inches in Americus. The Flint River Valley just filled up. If you've ever been to the little convention center there near the Flint River Valley, that valley looks huge, and it filled up with water because it was draining all this water down the Flint River Valley and caused tremendous flooding there. The picture that is on the lower left there is from Macon. And if you look at it closely, you can just kind of see it's right at the intersection of where I-16 hits I-75. Tremendous problems there, tremendous damage. There were some deaths from the floods as well. So you don't necessarily have to have a strong storm to have problems from this. Alberto was just a tropical storm. They didn't even retire the name. They probably should have, but they didn't. And so we like to use this little rule of thumb for figuring out what's an estimate for the amount of rain that you're likely to get from a hurricane or tropical storm. You take 100, you divide it by the forward speed of the storm. That's not the speed of the winds going around, but the speed of the whole system in miles per hour. And that gives an estimate for the rainfall in inches. So for Alberto, 100 divided by a forward speed of about 3 is 33 inches. That was actually pretty close to what the maximum was. Of that, 21 inches fell in one day. That's the state record for the most rainfall in one day from that storm. If you're looking at something like Hurricane Michael, forward speed of about 10, 100 divided by 10 gives a total rainfall at any one spot of about 10 inches, and that was actually pretty good as well. We'll point out that Florence, which hit the North Carolina and South Carolina in 2018, dropped up to 34 inches at some places. There's a CocoRa's observer, the lady, I've seen the lady's picture holding her CocoRa's gauge, and talking about how much rain they got. That could happen in Georgia, in the future. This is not something that is unlikely to happen in Georgia. And so we need to keep in mind that heavy rain could be a huge issue in the future in one of these storms. Tornadoes around hurricanes often form to the right of the track. This is Hurricane Katrina, and you can see the little dots there where all the hurricanes formed, or sorry, where all the tornadoes formed. And so almost all those are in the area to the right of the path of the storm. That's where the storm is usually the strongest, and you get the additive effect of the forward speed plus the speed of the hurricane itself to provide a lot of winds. And most of the tornadoes are in those spiral bands. Sometimes they're in the eye wall. You can see a few of them there right along the path as well. You will usually see the Weather Service put out some kind of tornado watch if a hurricane is coming on shore. And that will usually be sort of near and to the right of the track. I remember when Ivan came on shore in 2024, it was just making landfall, and we had a tornado in Athens. So that is a long ways away. You can have those tornadoes a long ways away from the center of the storm. So I've got to keep going here. Hurricane forecasting. Forecasting depends on both forecasting how the storm itself is going to grow and develop over time, but you also have to forecast what is steering that storm around. So that depends on having the larger circulation of the whole atmosphere, because that's going to tell you which direction the hurricane or tropical storm is going to move. And so you really have to have both of those. Forecasts are constantly evolving. They usually put out a new forecast at least once every 4 to 6 hours. Um, and so you cannot look at it at one point in time and say, oh, well, that's what it's going to be, and assume that that's true, because there's always going to be new observations coming in. Um, they put in extra observations by flying planes through them, by launching extra balloons if they've got the staff for it, and so on. So generally, I mean, the track of the storm is usually better predicted than the intensity, because we do pretty well at forecasting the large scale weather pattern through our current um, weather computer models. And I put this graph or this map here on the left-hand side just to remind you that if a storm is forming in the Eastern Atlantic, you have a long time to watch it. So it's not like it's going to hit you in the next week. That gives you plenty of time to prepare. Um, if the storm is forming in the Gulf of Mexico, on the other hand, you may only have a day or two to respond. And so you need to keep that in mind. Hurricane forecasting, you've probably heard about spaghetti models. Spaghetti models are one of these diagrams like you see on the left-hand side here, all these different possibilities for where the hurricane could go. And each of those lines represents a different model. There might be, only maybe 80 different models that are running on these hurricanes. And some of them are good at some things like rainfall. Some of them are good at other things like wind speed. They're not all equally likely, because some of them are designed to say, what if the hurricane keeps going in exactly the same direction? Which is not very useful, because it's probably not going to go in the same direction forever. And people on social media like to show these and show the worst possible case. So you're going to die because this hurricane's going to come over you when it's still 10 days away, if it's an Eastern Atlantic storm. And so you got to take that stuff with a grain of salt. Really, you really need to rely on the official forecast from the National Hurricane Center. They're the experts. They're going to be cautious. They're going to give you, likelihoods, probabilities of a place getting hit. And so that is something you need to keep in mind. All right. We all know something about the hurricane forecast cone. This is the new one. I'll show you the difference in just a minute from the old one. The hurricane track is supposed to be within that cone 70% of the time. That means 30% of the time it's not going to be. And if you look at the track for Hurricane Helene, it was right on the eastern edge of that cone. And a lot of the impacts were outside the cone. Some people think that all the impacts are going to happen inside the cone, but that is not the case at all. That's just where the center of the storm is. And if it's a big storm, it can have impacts on a much wider area. So you can see there, you can see whether it's a storm for S, H for hurricane, or M for a major hurricane based on the Saffir-Simpson scale of winds. They have cones for 3 and 5 days. And they also show now what happens when it goes on shore. The new thing about this is that before, the old cone is shown here on the left-hand side. They didn't really show where the impacts were going to occur. And now they have added impacts to the cone. So if you look on the right-hand side, you can see areas where hurricane force winds are expected, where tropical storm force winds are expected, and then there's some other things as well. So now they are finally telling us what the impacts are going to be once that hurricane comes on shore, which I think is going to be really helpful, because before that, people just didn't really know what to expect. And so this is a lot more useful information for those of us who are not right on the coast. So preparation, a lot of you probably already know a lot of preparation. I'm not going to spend much time on it because we're getting down to the end of our time. Preparation should include, if you're at the beginning of the hurricane season, so right now, you should be doing things like making sure you have an inventory of your property. Some agencies like you to pre-fill storm application with like USDA or something like that, so you don't have to do it right after a storm occurs. And I'm not familiar with which are the best agencies to do that, but I would imagine you could talk to your county folks and ask them if there's something they need to do to prepare for the season. Some of that would also be in the preparation recovery guides listed below. You need to do things like making an evacuation plan for your family and pets. where to meet, where to go. If you got to take horses out or something, you got to figure out a place to bring them. If you have livestock that you can't move, you have to figure out where you're going to put them and how you're going to feed them after the storm occurs. And so all that can be thought about well in advance. You can think about that at the beginning of the storm season. And the USDA has a bunch of preparation and recovery guides. These are divided by different commodities, so they have a different guide for livestock than they do for, say, cotton. And it will tell you these are the things you do ahead, these are the things you do during the storm, these are the things you do after the storm. Um, and keep in mind that when a storm hits, it's probably going to be 3 days before official government help shows up. Maybe more now because we don't know what's going to happen with FEMA. But you are going to have to help your neighbors the first 3 days, your neighbors, your coworkers in the counties, because it's going to take time for help to get there in most cases. So the more you can do to plan ahead of time, the better. So if you're in the tropical season, make sure you're monitoring the weather information at least once a day.
Something that extension offices can do to help.
Lindsay, is that right? Can extension agencies help with that?
Somebody walked into my office. I didn't realize I had
Oh.
unmuted myself. I'm
I was
so
like,
sorry.
oh, okay, no, that's all right. So during the tropical season, you're going to want to watch the weather every day, at least once a day. When it gets closer, you're probably going to want to watch it more often because even small changes in the track path can make huge differences in the weather you get. 50 miles of, if the eye is 50 miles closer to you versus 50 miles farther away, it's going to make a huge difference in what you see. So you're going to have to keep watching those and what the impacts are likely to be. If you're using a weather app on your cell phone, don't trust it because they only update about once a day and they are not designed to handle extreme, unusual events like hurricanes very well. So it's fine for general weather information, but I would not be getting storm information from a cell phone app. I'm on the computer all day, so I just use that. But if for people who do use apps, just remind them that they're not really very useful for that kind of quickly changing weather conditions that you expect to see in a hurricane. As the storm gets closer, there's other things you can do. Take pictures of crops and property to establish their pre-storm condition. If the cotton's going to blow away, you need to know what you're losing. And so you need to take some pictures and maybe do a little bit of sampling ahead of time to figure out what the potential yield might be, because that's going to be important for your insurance claims later. If you've got animals, make sure the feed is in places that you can get to and that it's going to be somewhat protected from the rain. It's not going to get flooded out. You don't want equipment to be in low-lying areas or cattle, because flooding is not good for electrical equipment. If you need fuel to run, water pumps, or if you have a dairy, you need to make sure you got plenty of that on hand ahead of time as well. And then just generally key safety tips for everybody. As you get closer to the storm, know what your risk is in your evacuation zone and be prepared to act. Have a plan for your family and a disaster kit. And if you're in an area where they have an evacuation order, get out as quick as you can to a place that's safer. Listen to official sources for the most important information about where to go, when it's going to come and hit. Usually, when the winds get too high, they can't send out ambulances or emergency equipment anymore. So then you're stuck. So make sure when you're going to be on your own. If you're not evacuating, make sure you secure your home and find the best place in your home that's going to be safe. And I just want to close here in the last few minutes talking about hurricane insurance. There never used to be specific hurricane insurance. I know some crop insurance does have, and some homeowners have hurricane components, but this program that's called HIP-WI is a specific hurricane insurance program that began right around 2018 as a hurricane only insurance. So you had to actually have a hurricane in the state for you to be able to claim the insurance. And at that time, I wrote something in my blog that said, I'm not sure anybody would want it because we've hardly ever had any hurricane force winds in the state. Of course, the last year has proven me wrong, but in general, there just didn't seem to be much reason. But they expanded it a year or so later to include tropical storm damage at half reimbursement if you choose to purchase the tropical storm version. So to claim a full payment, you have to be in a county that has observed hurricane force sustained winds. Sustained winds mean the wind is constant, or it's the wind average over at least a minute. Gust is like an instantaneous, and gusts are usually higher. But just because you had a gust that was 90 miles an hour doesn't mean it's sustained winds. They're usually lower than that. So you either have to be in a county that had that wind or a county that was next to it, a contiguous county. Um, Wind measurements that are accepted for that are actually limited to very few. The National Weather Service offices that have 10-meter towers are acceptable. Unfortunately, a lot of them are on hard power, and in Helene, a lot of them lost their power, so they lost their observations. They had to figure out what to do later. Amateur weather observers, amateur weather stations are not accepted. So if your neighbor had a wind gust of 120 miles an hour, you're never going to get them to accept that. They won't take ours at the UGA stations because our towers aren't 10 meters tall. They're only 3 meters tall. And then to get a half payment, a tropical storm payment, you have to be in a county that has tropical storm force winds, so 34 to 75 or thereabouts. Plus, that same county also has to have a 4-day rain total of 6 inches or more based on a limited number of acceptable rainfall observations, and that does not include CoCoRa's because their records are not long enough. So, this year there were 2 possibilities. Debbie had quite a few claims for tropical storm force, and those were a little bit further to the east of where the Helene force winds and the Helene HIP payments occurred. And then that we had the second one with Helene that came in. Areas that didn't get one often got the other. You can see it covered a lot of the state, except for the areas right along the coast, which is odd because I know if you look at where the power outages were, the smaller map on here, a lot of the power outages were along the coast and just to the inland. That's because there was an interaction of Helene with a front in the area, and so the strongest wind gusts were not actually right at the eye, but they were to the east of the eye. And Augusta had tremendous problems with wind gusts there. Some of the other places like Midville too, it's just tremendous amounts. And they didn't all get hurricane payments because they were not in that strip of red that you see in the larger map there, which was based on what hurricanes are supposed to look like, which is the circular, wind around it. They don't actually base it on the actual observations. They base it on what they think was supposed to have happened. And I have gone round and round with these people. They're doing the best they can, but they're not meteorologists, so they don't understand that it doesn't always work that way in real life. So the UGA Weather Network stations were not even allowed for the claims because the towers aren't tall enough and they're not archived by NOAA, even though they all operated during the storm because ours are on solar power. So lots and lots of people complaining about why didn't I get that? My neighbor had high winds, or I had rain in my half of the county, but maybe the other half of the county didn't have as much rain. They only do one number for the whole county. So if you're in a county that had a big gradient of rain, then you might or might not have been over that 6 inches. And so that is something that's going on. I just wanted to end with this year's predictions. The current situation is we're in an ENSO neutral. That is usually consistent with a more active Atlantic tropical season. The ocean temperatures in the Atlantic and Gulf are warmer than normal, but they're not as warm as they were last year. So that's going to probably decrease the number just slightly. Colorado State is one of the groups that does some of the early seasonal forecasts. They named, you can see on the bottom left there, the forecast for this year is for just slightly fewer named storms than last year. Same with hurricanes and major hurricanes. NOAA's going to release their forecast in about a week. It's probably not going to be a lot different than this. They're all pretty similar. Seasonal forecasts cannot say where the storms are going to go. They could all come to Georgia again. Not likely, but it's possible. They could all go to Texas. They could go up the East Coast. We don't know because those storm paths depend on the weather at the time. And so the best we can do now is say what's likely to happen. So here's my final slide. This is hurricane resources, and you'll get these in the slide set that I sent out. National Hurricane Center is kind of the big kahuna of any place that you want to go to get official forecast information. If you like to look at lots of maps, spaghettimodels.com has all these different things like, sea surface temperatures and lightning and all the different model runs that you can get and so on. It tends to be a little bit loud. They hype things a little bit, but it has a lot of stuff in one place, so that's good. For people who are not necessarily farmers, the Resident's Handbook to Prepare for Natural Hazards gives some really good advice about preparing for the winds and rain and a hurricane, as well as other natural hazards. And for farmers and ag producers, the USDA Preparation and Recovery Guides for Georgia producers is there at USDA. We're gonna tomorrow. I think the Southeast Climate Monthly webinar is going to have somebody talking specifically about that the last Tuesday of the month. I won't be there because I'll be on the road, but they're going to have somebody from USDA talking about those as well. And then the hurricane tracks, the historical hurricane tracks, then are listed there again. So that's all I've got. We're just about out of time. I am happy to take questions. Let me see if I can. Trying to see if I can get a list of everybody. Almost everybody. I'm going to do a screen capture. Make sure that I've got that. And let me escape out of this. Stop share. All right. Thanks again, everybody, for coming. Any questions? I've probably just blown you away with all this information. All right. Let me go ahead then. I'm going to stop recording now